So when you are building event-driven systems, it's important to understand the types of events you can publish and their trade-offs. Your choice affects coupling, throughput, latency, and how teams can work independently. In today's video, we are going to talk about notification events or event notifications. But first thing first, let's try to understand what is notification events. A notification event signals that something happened, but the event itself contains minimal state or information. It doesn't include all the data about what changed. So let's explore a little bit more about notification events. So now, here we have our customer microservice. So the customer microservice published an event, and now we are using notification events pattern. So the event itself, as we can see, contains minimal information. So for example, here we have the event type, which represents the type of event, right? What has happened, right? So the customer address changed. This is the type of the event. As we can see, we don't have here the metadata or the information about the address itself. So for example, we don't have the zip code or postcode. We don't have the name of the street, the city, and so on. And of course, here we could have more technical data or metadata, okay? This is the concept. Notification events, we set minimal information. So now let's try to understand here the advantages of using, for example, this pattern. So the first thing is minimal information. As I was telling you guys, as we can see, we have minimal information, very small data related to the event itself. Now, as we have, for example, here, this minimal information, we are going to have an ultra lightweight payload which will reduce network bandwidth and processing overhead. And also, for example, as we have this kind of small information, it will be very fast in terms of serialization and deserialization across the system. And of course, as we are thinking about the cloud nowadays, we are going to have lower storage costs for event logs and message brokers. And of course, as we have the small amount of data, we will reduce the memory footprint in consumer applications. We are going to explore it later. The other trade-off that we can consider is the fact that using the notification events, we can reduce the data synchronization risk. Let me explain you better. So now here we have the decision microservice. So the decision microservice is a consumer microservice. So it will consume the event, okay, that we have just published. And now what about the data? So here is the fact that, for example, for this particular case, our consumer microservice will use, for example, here the customer ID to get the information. So here what we can understand is the fact that when we are using notification events, using this minimal information, consumers often need to fetch the data if they want the full picture. So the consumers fetch current data from the source of truth. So another trade-off is the fact that, for example, using notification events, the consumer services or microservices or event systems are less likely to receive outdated information, which is something that we call by stale data. Now, let's move on. So let's suppose that we have published this kind of event. So this type of event are very cheap, right? And the producer can send them very quickly. And now let's understand the consumer side. So having this kind of pattern, we can give the consumer side the flexibility to catch or to fetch the data whenever they want. So the consumers decide when to fetch the full data. And this is amazing. So this is what we are calling by the coupling of timing and data. So having this type of event, we can understand that we can add more consumers without changing, for example, the producer contract. And even, for example, the contract between producer and consumers will not break so easily. That's amazing advantage of using, for example, notification events. So far, so good, guys. Now, let's try to move further. So here we have our customer microservice, but now we have 3 extra consumer microservices. So now, the customer microservice publish an event. As we can see, the event type is customer created event. Now this time, every single consumer will consume the event. Now, we need to understand that as the customer microservice is publishing an event that contains minimal information, so we are using notification event, if we have 3 microservices consumers, that means that we are going to add 3 extra gRPC or HTTP call for every single event. You can say, okay, it's not so bad, but you need to understand at scale, for example, thousands of events per second, this creates significant traffic across the network and adding extra load on the producer microservice. So we can have problem. For example, can you imagine having more than 10, 20 microservices, all of them reacting at the same point, making calls to the producer microservice? So we can add, of course, some extra load on our producer microservice. So this is something that we need to understand. When we are using, for example, event notification, or when we are trying to decide which type of event-driven pattern we are going to use. So remember, using the event notifications has some advantages and disadvantages. And here we are talking about the trade-offs. So let's add something. So this pattern notification events is not the best choice if you want real-time processing because it may add some latency. So each fetch call adds a round-trip delay. So what I mean is, for example, let me explain very quickly. So Kafka delivers the event in 5 milliseconds. But the consumer then makes an HTTP call or an HTTP request that takes 200 milliseconds. The total time before the consumer can act is not 5 milliseconds no more. It's 5 milliseconds plus 200 milliseconds that we had from this call. So this is what I'm trying to explain to you guys in terms of, for example, latency. And now let's suppose that we are talking about the worst case scenario where we have, for example, failures. So when we have failures, what we can add? Retries. So if we add retries, this latency grows even more. So this is something that we need to keep in our minds, guys. Don't use notification events or event notifications if you want real-time processing. So let's move on. Now, we understand that notification events requires that, for example, if the consumers need the full picture, the consumers need to make the call, right, to the source of the truth, which is the producer microservice. Now, we can understand that, for example, here we can make a call, HTTP 503, service not available, second call also, for example, from the second consumer, HTTP 503, and also, for example, bad gateway. So this is very bad. We can understand that we have here an hidden coupling. So the consumers became dependent on the data source availability. So if this microservice goes down, we have a problem, right? So this is what we can understand. So when we are using, for example, notification events, sometimes we can start adding some hidden coupling because as we need to fetch the full picture of our data, okay, we will rely on the microservice producer, which is the source, okay? We will rely on its availability. And this is something that we need to consider, okay? If it's nice for your business case or for your system or not, you need to understand that. And we need to always keep in mind the concepts related to reliability and resiliency because they are so important. So having this kind of hidden coupling, we understood that, for example, we can have cascading failure risk. So what we have here is the fact that, for example, if the data source is down, what I mean by data source is the microservice source, okay, of information. If this microservice is down, all consumers may fail. And the failure, we know that the failures span multiple systems. And for example, in terms of debugging, while we have event-driven architecture, is very hard to debug event-driven architecture or event-driven systems. So that's the reason that we need to understand it, okay? So these are the trade-offs of notification events, and we can move farther, for example. So let's talk about consistency challenges. The first thing that we need to understand is the race condition, but let me give you an example. So here we have our customer, okay? The customer has just submitted, for example, you want to buy something on our e-commerce. Let me say that you want to buy GameCube, okay? But its location is in USA. As we can see, this street name, okay, location address is a street in Springfield, USA, right? So far so good, guys. Now, as we are going to publish event, we can publish using some different patterns, but let's use, for example, transactional outbox pattern, which is a nice pattern, okay, in order to publish events and solving, for example, the dual rights problem. So let's forget about that because we have already a video. Just go and watch it there. Now, the customer microservice published an event using notification events. So we are sending the minimal information. Now, the other microservices, which are the consumer microservices, they consume the event. So as we are using notification events, we know that we can have this kind of, let's say, advantage of giving the flexibility for each microservice to fetch the full picture whenever they want. So for example, first, this decision microservice will just fetch the data. But meanwhile, it's fetching the data, maybe the customer can change his address. As we can see, now the customer just changed his address. And now we publish an event, which is the customer address change. And as we can see here, now in database, from the producer side, from the origin, from the data source or the source of truth microservice, we have a new location address, which is in Portugal, Porto. So the first one, when we created the customer, his address was in USA. Now he's updated the customer changed the address, and now we are in Portugal, Porto. Okay, so this is what we call by race condition, but for this particular case, okay, this, let's say, decision microservice may fetch all data or the new data. We never know. But here is a little bit problem. For example, for analytic microservice, we can have eventual consistency gaps. So consumers might see different data states. For example, this microservice can see, for example, that this customer address is in USA because it was faster enough to get the data or to fetch the data before the customer changed the address. And now the analytic microservice is seeing a different type of data because the address here is in Porto. So here we have some consumers that might see different data states. One, which is this one here, that was a fast consumer, okay, may see, for example, the data which is related to USA about the location address, and this analytic microservice is actually seeing the data that contains the location in Porto, Portugal. So now let's summarize when to use and when not to use notification events. So first, when to use it. So we can use it when the data is too large, or even when, for example, the data is frequently changing. So instead of sending this large payload that is changing often, we can change minimal information. So sending only the ID and let the consumers fetch the latest state when needed. So this is when, for example, we can use notification events, as I was telling you guys, when the data is frequently changing or when the data is too large. And also, for example, we can use the notification events when we have, for example, different consumers that need different data views. So, for example, each consumer can query the source in order to get the exact slice of data it needs, avoiding one-size-fits-all event payload, such as this event, for example. Okay, so what we have here, for example, is the fact that, for example, decision microservice can get only, for example, the customer information, let's say. And also, for example, the billing microservice can get, for example, this slice of data, for example, the customer ID, and also can get, for example, the social security data and financial information. And moving further, for example, here the analytics microservice can get its own data too. So for example, it just needs, for example, the customer ID, the address, and the audit trail. So this is nice, right? So each consumer, okay, will query the source system for the exact slice of data it needs. That's amazing. That's what I mean by flexibility. And of course, we can also use notification events when we have sensitive fields that aren't exposed in event. In that order, the access is enforced at the API layer when consumers fetch details with proper authorization. And of course, we can also use notification events when we want more loose decoupling. So for example, the producers, as we can see here on our side, so the producers stay lean, only signaling that something happened. In that order, we are leaving the consumers free to decide how to retrieve and process the data. So now we can see when not to use notification events. So first is if the consumers can't wait for an extra fetch. So in that order, we can use another pattern, which is the one that we are going to cover in the next video. So we can send the full state in event instead of sending only the minimal information. Okay, so we can avoid using notification events if the consumer can't wait for an extra fetch. And also, we cannot use it when we talk about the network latency. So the extra callbacks introduces round trips. So it's not suitable for low latency workflows. Okay, so we need to think well when we are talking about notification events. So if the API behind the event isn't highly available, consumers will fail, as we can see here. Okay, consumer will fail even if the event was delivered. Okay, so consumer can consume the event, but once they try to fetch the data, they can fail. And the last but not least, we need to avoid using notification events because as the consumers fetch later, okay, they may see newer or inconsistent state. So this is how I decide to summarize this topic. So think well before using or before producing events. Event-driven architecture is amazing, but there are trade-offs and we need to understand when to use one pattern or another. Okay, so this is what we are trying to see in this series. So in the next video, we are going to cover the other pattern. So guys, I hope that you enjoyed this video and please leave a like, leave a comment, subscribe if you are not yet, and give me a suggestion. So see you in the next video and bye bye.